Hello, today we're going to be solving for a specific variable in an equation that contains other unknowns. So notice that in my first example we're asked to solve for g. Well, g isn't surrounded by numbers that we know, it's instead surrounded by unknowns m, h, and w. But to get g alone, we still do the same processes. So if I actually had numbers here on this in this equation, what would I do in the order of operations? Well, first I would multiply m and g together, and then I would add h, and it should be equal to w. So to get g alone, we want to undo these processes. Well, the last thing I said I was going to do is add h, so we want to do the opposite of add h, which is subtract h. So we're going to subtract h on both sides. And so mg is equal to w minus h. And now what's happening to g? Well, it's still being multiplied by m, so we need to undo that. So we'll divide both sides by m. Well, the m's are going to cancel. I'll just sit right over here so I can divide m. The m's cancel, so g is equal to, well, there's nothing to simplify in any of these because w and h aren't like terms, so I can't subtract. There's nothing that is in common with w and h and m, so I can't divide. So really it just stays like this. And that's it for that problem. Let's take a look at another one. In this problem we want to solve for b. This particular equation, AB plus BC equals T, has its own unique challenges in that there are two different B variables in this equation. So to get B alone means we need to somehow turn this into just one B. And what we're going to do is think about the distributive property. Now we've done the distributive property where we've seen a number, and let's say 7, and we've sent it through to both the x and the 3 here, so 7x plus 21. Well, what if we wanted to undo that? What if we notice, hey, this has a 7 and this has a 7? So let me put that 7 out front, and I'm left with x plus 3. Well, that's what we're going to do here. Both of these things have a b. So I'm going to take a b out front, and if I divide out a b from ab, divide that out, I'm going to have a left, plus, and I'll divide a b out from bc, and I'll have a c left, still equals t. And so you can see that if I were to take the b and redistribute it through, we're going to get a times b plus b times c, still equaling to t. But now I only have the one b in the equation, and it makes it much, much easier for me to get it alone. So what we did here, we undid distribution. And so finally, let's get b by itself. Well, b is currently multiplying to some number, which is whatever a plus c is. So we want to undo that multiplication, and we will divide by a plus c, so that they cancel. And we'll divide this side by a plus c. So we'll divide a plus c. And again, there's nothing in common with the t, the a, and the c that we can take out of all of them. So we will get b equals t divided by a plus c. And we're done.